Well, what if we've got a quadratic function, x squared plus 5? We don't expect to get the same thing out, but we are going to go through the same process. Now, as you work through these problems, you'll probably find shortcuts that you can take. I do not want you to take any shortcuts at this time. I want you to go through and do this by the definition. In the next few days, we will learn shorter ways to do this. We'll learn some specific rules for taking derivatives, and you'll get to a point that with most problems, there's much less work to do than what we're doing now. But for the time being, I want you to work through it the same way each time. So let's walk through another one together. We're going to take the limit as delta x approaches 0, x plus delta x. So we're going to replace this x here with x plus delta x squared plus 5. Then the minus sign that was right here, the function itself, x squared plus 5. Remember to keep it in parentheses or distribute that minus sign through over delta x. Continue evaluating. You need to expand this binomial here. You can either write it out and FOIL it, or remember, square the front, square the back, twice the product of the two. Plus 5 minus x squared minus 5 all over delta x. Alright, let's look for things that can cancel out. Minus 5 plus 5 minus x squared plus x squared. So now we've simplified this down to the limit as delta x approaches 0 of 2x delta x plus delta x squared all over delta x. Still, we can't evaluate it yet. We'll factor out a delta x. Don't forget our limit terminology here. Delta x. The limit as delta x approaches 0 of delta x times 2x plus delta x over delta x. Now we can cancel these out, and we can also evaluate this limit now, and we can evaluate this limit and find that it is 2x. So we have found out that f prime of x equals 2x. Provided our initial function is x squared plus 5, we've worked through and found this to be the solution to it. And we're asked to find the slopes at 0, 5, and at negative 1, 6. Well, let's look at that. 0, 5 means we're going to plug our x value into our f prime function. F prime at 0 is 2 times 0, which is 0. Our other point that we've got is negative 1, 6, negative 1 comma 6. So we do that. F prime at negative 1 is 2 times negative 1, which is negative 2. And we could do that for any point that's on the curve. Since we have gone through and determined that the derivative is 2x for this function, we can find the derivative at any point that's on the curve now simply by plugging in the x value into our derivative function.